Hey, what's up? How's it going, everybody? Am I too loud? Just checking. Happy Halloween. Happy Halloween. So it looks the same, only it's not. It's one of those things that I kind of like promise myself that I do, and that's not do the same thing twice. Hello, welcome. So, I mean, the advantage of having these clips is just it's 100% gold. I'll tell you what. You can make parallel circuits like jam. It's pretty cool. All right, so the difference between the previous version of this and this is that I got the trigger coil, and I have it branching off and coming around through a diode and a capacitor back in to another diode, which dumps into the collector of the transistor. Now, why I did that the way I did it is because I've tried it all the other ways. I've rounded it. This is pretty cool. It doesn't work the way it's supposed to. As a break, but what it does is it prolongs the motion of the motor after you turn it off. Everything still runs basically, but it runs at a depleting rate because of loss. It's just, it's natural. The way I set this up, it generates about 33 volts when you cross over at that speed, in between 35 and 40 volts off of this coil here without a core. So, but there's no amps, but I have the capacitor which will transform, it'll change it. So when it's running, when it's on, you can hear it when the capacitor dumps. You can like hear it speed up real quick. So the basic extra part that I added on is virtually, you got the capacitor in the end, the positive end of the capacitor, the trigger coil You got the positive end of the trigger coil hooked to the base, and then you got a branch off of the connector here. And it goes from here, and then it branches off through the circuit right here. And it's virtually just a parallel connection because of this connector. So it goes from the trigger coil both to the base and to the circuit at the same time. And then this just feeds back into the collector. So virtually the trigger coil, I have a feeling right now if I take the 2 drive coils away, that I could run this just on the trigger coil. Maybe not as fast or as good, but you know, it would probably work. Absolutely. That'd be awesome. All right, let me get a voltage reading on what's coming off of that coil right now. Hey, what's up, guys? Sorry I haven't been paying attention. Right now, I am currently seeing if I can get this thing to move a little bit more than it should when I turn the power off. I'll explain exactly what I've done. It's very simple. I don't know if it's going to work, though. 40 volts are going out right now. Okay, that's the trigger coil voltage. Then turn the power off. Turn the switch back on so it'll ground properly. If I cut the switch, then I think I cut the ground too. I don't want to do that. So it's 2.88 volts of backlash, and it's going up. So that's what we want to see. It's 2.92. It went up about, you know, very little bit, but it was started to go up, and that's what we're looking for. After you turn it up, turn it off, and it starts simmering down, it'll start to go back up. The backlash reading is what I'm talking about. So you know, if you got it hooked up right, you'll get a reading after you turn it off on your voltage. It like feeds back in. Maybe it's hooked up wrong, but anyway, it's a good indication that what I'm doing here is working the way I want it to. So virtually what instead of turning the trigger coil into a brake, I've turned it into a booster. Well, kind of a generator. I'm not really doing it to generate electricity. I'm just seeing exactly how much voltage is being generated. I know that sounds weird or like an oxymoron, but it's just to see how much I'm actually putting back into the collector. And each time it passes this coil, it's going to trigger the base. So automatically you get both of those happening after you turn it off. So that's kind of why I did it that way. And we're still generating 9 volts. It's not magleved at all, so it's just kind of sitting on a bearing right now, the rotor. We're still getting 2.18 volts of backlash on the system here. So I've put this wire here in the ground, and it doesn't really work as a brake. I mean, it might slow down a little bit faster, but essentially it all kind of moves the same amount when you're trying to brake it. But when you're intentionally trying to use it to cycle through the system, and the reason that it works is because the trigger coil is also grounded. And that's why these clips are so nice. So it's also grounded, so it's all grounded, this system, and it's all in a cycle. It's all in a circle, basically. So it'll siphon off through the ground, but it's forced to go through the system via diode and other things, capacitor, like a brake system in reverse. I just did it that way because I couldn't get the brake thing to work. I just couldn't, or to work to my satisfaction. It wasn't very noticeable. Happy Halloween, everyone. Well, before we get all uppity up again here, let me open up the hood real quick. It's a 3-magnet rotor. These are very powerful magnets. They're 40 millimeter by 20 millimeters squared. Very strong. Very strong. Okay, so we got main drive right here. It's hooked to the breadboard on the emitter leg of the transistor. So this is hooked to emitter, and then it goes through some very specific connections. Let me think here. There's 3 AC connections and 3 DC connections in this coil in series. So it's not really difficult, but you connect 3 wires together and then you put a diode. You connect another 3 wires together and you put a diode, and you connect the 4 wires together, and you can either put a diode or that can be the end of the coil. But I got a diode, and then I got it hooked up to a pickup coil over here, which is about half the size of this coil. About 5 strands, 6 strands instead of 10, and it's a little bit shorter too. I actually made 2 pickup coils, and I'm going to hook up the second one kind of right where this trigger coil is. Now this functions both as a generator coil now, and a drive coil, and a trigger coil all in one. It's pretty awesome. But its main function is a trigger coil. Everything else is kind of experimental, really. But I do have proof that when I turn off the power, the residual will go up. And that is unheard of in my experience until hooking it up this way. And that means that the voltage is then being pushed through the system, which is awesome, like what it's supposed to do. You know, you just need to get the diodes in the right place, maybe throw a capacitor in there. Capacitor is unnecessary, though. It'll run smoother with it, but it's not necessary. I put one in there because, you know, I have a bunch. I'm going to use some. Doesn't really matter, though, because it'll function without it. All right, so this over here, this diagram, all right, let me see here. That good? Yeah, that's good. All right, so you got the way you make the coil on the left. You got the diagram of the motor in the middle. Got the legend and the name of the motor on the right. Okay. Perfect. All right. So right now, while it's on, I have a very strong feeling that I am aiding the speed of the motor by a lot. Even the 35 volts are being AC volts are being generated for the system here. There we go. That's 2,000 RPMs right there. And see, it's conceptual. Okay, like if you wanted to put something, attach, or make, the rotor do something else, you can always equip it to do something else. It's just a piece of plastic that I printed off my 3D printer. And I'm in my bedroom, so it's going to be conceptual. It's going to be simple. That's why it's called simplicity strength. But yeah, if you wanted to put like lawnmower blades on that, bring it into a shop and go for it. That's awesome. It'll work, I'm pretty sure. Mm. Maybe a fan or something, like just a fan that moves air. I can feel air coming off of this right now, just from the slight imperfections in the plastic. Good day, Brian. How's it going? Because the only reason, it wouldn't be a perpetual motion machine, because eventually it would stop, because it would, just totally destroy time and space. But what happens is that it continually increases in speed. That's what really happens. If it's going to work, it's not just going to level out at some speed. It's going to continue to increase in speed, or it will stop. So no, not a perpetual motion machine, but I think it's pretty cool. Nice. Yeah, anything that wants to save some for the way back is never going to win. We all know that, right? It's just reminded me of a clip from a film. Like people my age, the movies are so big. Even if you don't watch them anymore, they influence the life like tremendously. It's got a lot of sway, a lot of power. Take it with a grain of salt, because but they do get the lowdown. I'm talking about Hollywood on things before they actually become things. Probably due to some connections up in there. You know what I'm saying? I'm not saying like they're first movers or anything. I'm just saying they got a connection somewhere. Yes. These are, if you're talking about them all facing the same direction and being north, yeah. It's a, no, I haven't hooked up the SSG. This is just a standard connection. But let me show you. I got the light for the SSG. I got all the diodes I would need to hook it up. I just haven't done that. Don't, it's, I would say that this system is very efficient right now. I mean, it's not like the remarkable or anything, but I'd say that the efficiency has gone up significantly since I added the pickup coil to the system. So this little coil right here really like shaves off, you know, like 700, 700 milliamps from the draw to get up to 2000 RPMs. It only takes like 0.4, 0.3 amps now instead of one whole amp. That's a win, if I ever said so myself. I think this combination, this connection, especially these multi-connectors where you can put the two ends of the trigger coil in one, and then you can have your 4 prongs coming out the other side, so you can do 2 and 2. But yeah, it just worked out so well that to get that, if you needed to go 2 ways off of one end, this is the way to do it. Freaking cool. You know, you could do it with solder and stuff too, but I mean, yeah, and then to make get a clip with a diode built into it, man, that would be freaking awesome. Then you don't have to use 2 clips to do a diode. Tuning this. You've been playing with graphene? Oh man, yeah, that's cool, man. It's dangerous. It's like really powerful, man. That's awesome. I'll look that up. The neutrino box, man, that's awesome. Tuning this. Let me think here. I just read that upside down, so hold on. Happy Halloween, everybody. It was not tricky at all. I still can't run it with a signal generator, I don't think. I don't have like, I mean, I got to get readings off the drive that I don't have yet. I want to get the frequency rating so I can just jump right in. But I do not have that right now. Let's see what I can do to get one real quick. right, let's see if we got it. Let's see if we got it. All right, we got a frequency of 41 hertz at the moment. Oh, there we go. Hell yeah. $160. There we go. 200, 220, 270. Wow, 280. Okay, leveling out about 250. $270. 0.3 amps. See what I mean, man? Low amp drop. 0.4. Okay, it's going up a little bit. 369. Woo! That's an awesome number. 400. 420. So about 270 on the frequency for the drive coil and the pickup coil in series. That's for the series circuit there. Cool. Yeah, I do a lot of 369 stuff. Frequency, capacitance. I try different things. And it's not, you guys, when I say that I don't read, it doesn't mean I can't read. I just choose not to read. But I learn better from like pictures and talking to people, stuff like that. Especially when you're building something, man. That's why I believe that an instruction manual has both picto and word instructions, just standard now, because they know people learn in different ways. Happy Halloween, everyone! Happy Halloween! Uh, uh, so cool. Let me get that. Where did I put it? Uh, Oh, I remember. So this is the last piece of this motor. It's literally like 3.5 turns of the same wire that the pickup coil was made out of. So it's just essentially just a little nipple of a freaking coil here. And it'll be rounded series, and I want to put it on top of the trigger coil, like right on top of it. But, you know, I'll have to elevate things a little bit for that to work. I mean, right now it's equal, pretty much. Everything's the same height, but if I do that, it'll change it. So I don't know exactly, quote unquote, what to do. I could put it like in front, like right here, or right next to it, I mean. I think that would work, honestly. I mean, the magnetic field from these magnets are practically touching each other right now, just from being at 120. So I think that would work even pretty good, actually. Really neat. Mm. I want to get some more readings on the trigger though. I want to do that. So flip these connectors. Boom. Right. So this one says the AC voltage is at 20 volts right now. Capacitance is at 100 NF. Frequency is at 70. It's got a much lower frequency than the drive, which is, I guess that's normal because there's no like electricity being pushed through it with current, really. It's all being made by the magnets. So I think it would be less because of that fact. Yeah, about 90 hertz right now. .022 amps being generated. So like no ampage whatsoever, really. 0.024. Let me change it to AC. 0.07. Oh, wow. Okay, we got a nice wave here. It is all going downward, though. Wow. Here, let me see if I can tilt this up so you guys can see it. between 300 and 400 volt spikes. It's all negative though. It's all south. Oh wow, that was a lot. Holy cow. And then here the power is completely off and you still get the wave there. So that's definitely a generator. I think that's weird how it's like that. I think because I don't have any diodes like, no, I don't know. I mean, I do have a diode, but it's, well, maybe I've created something that is truly unique here. I don't even know what's going on anymore. Based on the readings, though, we're still getting like between 70 and 90 volt spikes. That's pretty neat. All right, I'm going to rehook this up again. To the drive. And I'm going to get the oscilloscope reading on it. I might have knocked something. Sounds like I knocked something. Yeah, I pulled that out. My bad. Huh. Whoa. Okay. Let's not be an idiot. All right, we're starting to develop a wave. Again, it's pointing downward pretty much. So I guess we need to figure out a way to like make it more whole. Still works pretty good for being a, a negative motor. Oh, you can see the cap dump now on the screen here. At least that's what I think I saw. It's like a huge spike. Like that one right there, man. Yup. Wow. I wonder, because I normally don't get those huge amp boosts that I was getting right there. It went up to like 1.3. Hmm. Yeah. All right. My first name? Uh, uh, oh, yeah. Well, I think we all know. If you don't know, my name is Mike. All right. Mm. Well, it's actually Michael, but whatever. That is the first time I've actually seen it like work the way it's supposed to. I think that's what it's doing. So let's make sure all these connects are good still. So we'll go 15 in, 16 in. Give it a whip. Oh, that's what it is. Yeah, the battery's about to die on this thing, so. And if I unplug, I gotta unplug my phone to plug it in. So I'll definitely have it ready to go for the next one. Still working right now, but yeah, I think that when I twist them, this is what happens to the wave. It gets weird. 0.4 amps, man. That is low for how high the voltage is. Oh wow. We're gonna be at 2222 in just a second. 2200. Boom. Yeah, simplicity, strength. Boom. You know what that says, right? That says it's going 2222, basically. All right, so I got a way in my mind that I can kind of test this and see if it's working or not. What I wanted to. Don't turn the power on at all. Just spin it. Now, if it's working, the first few seconds there, it should increase in speed and then slowly taper off. How do I test that, though? It should literally, you spin it as fast and as hard as you can, and it should increase in speed for the first few seconds. And then slowly taper off. That's how I hooked it up. That's what it should do. Mm. Now it says in order to do the break, you simply just move this wire into the ground position. So cool, man. I'm just glad that the trigger coil is like well enough built that it'll function as all three: trigger coil, generator coil, and a drive coil in this case. All right, we're getting residual on the meter here over here, the power supply. So I'm going to spin it again and see how quickly it will. All right, let's go. Yeah, it's going up, still going up, still going up, still going up, starting to go down. Exactly what I said would happen. That's so cool. When you get it right, man, you feel good. Currently, I only have one switch hooked up, Brian. Just one. One transistor, one switch. I could do them parallel where I need more switches, but it's not hooked up that way right now. Yeah, I could test each part of it. I want to test the trigger coil by itself, but I need to think about that because then we need a connection to the collector and the emitter from the trigger coil. I got two of the connections that I need already, but I need the emitter connection. And I think, honestly, now that I think about it, as soon as I do the emitter connection, it's not going to work anymore. Damn. Well, I'm going to do it anyway, just to make sure that I'm right about that. Because I got 4 more holes in my connectors that I can use. Yeah, I had it hooked up where each part that in the drive coil that's connected via diode, I had it hooked up to its own transistor. So yeah, I could do that. Done it. Happy Halloween, everybody. You got kids, have a great night tonight. You don't, have a great night tonight. Yeah. Then go trick-or-treating with my kids. It's going to be awesome. So I'm thinking maybe I can hook up, since it's for a capacitor, you know, like one of these doohickeys. Where is it? Right here. One of these bad boys. It's got like 20 capacitors on it. Ah, you mean like put the... Yeah, I could try that. Yeah, dude, that's actually probably what I should do. Set the trigger coil apparatus up on a different transistor altogether to see, test whether or not it's working at all. But I really want to hook it up through this, because this has got, you know, rectifiers, capacitors up the wazoo. It says max AC 50 volts times 2, max ampage 6 amps times 2. That's input. Output max 600 watts plus 600 watts. So each, so I guess it's it's going to be 600 watts altogether, I'm pretty sure. Maybe 1200 watts. 1200 watts. It says 600 plus 600, so I'm thinking that's 1200. And put that where the cap is. Have the line go straight into the Thunderbolt right there and come out the OV. That'd be sweet. I think I think that's what's gonna happen. That's gonna be nice. And it's got indicator lights on it and everything. It'll tell you whether or not it's lighting up or not. As for like holding all the stuff that I could do with like my amp funnel, putting a coil behind a coil through a core and all that stuff, I can't do that with this axial flux design. It's not going to happen. Not this one. So, like, what I'm getting at is there's no core here, there's no core here, and there's no core here, and there's not going to be one. You really don't. I mean, even if it increased the power by 4 times, it's just not worth it putting it in. It's not. And then just imagine this being increased by 4 right now. 4 times right now. That's stupid, man. That's like 8,000 RPMs. These magnets would be flying everywhere, dude. That's just, it's not smart. I'm not the safest person in the world by any means, but I do appreciate some small amount of safety. So, and I was thinking, I don't even know what I'm thinking about the cores, because I tried putting, where is it? This one, this generator coil with the soft iron core underneath here, and just the way that it's built right now. It doesn't even have like enough torque to keep moving based on how strong that suction is. I mean, even if it was on right now, it wouldn't. I mean, I could lift it up a little bit. I could raise it a little bit. Yeah, ballistic shielding for sure. Any faster, we're going to be in trouble. Yeah, I'm sure somebody's got an opinion about my not wanting to use a core. That's fine. I don't really care. And I think you're wrong, honestly. But I can raise this up and then it'll work less efficiently, but it'll have less drag on the rotor. Is that too high? Let's see. Is it too high? Might be a little bit too high. Don't want to start a fire with my glue gun. He was resting right on it. All right, so I will hook this up. I'm going to glue it right to the table right here. Right in that spot right there, because it doesn't really matter where you put it. Got to get some batteries today, some AAAs for this one. This is an awesome multimeter that I'm using right here. But it's dead, basically. Just need to get some more batteries. Yeah, they definitely changed the well, I mean, all you got to do is reposition everything once you got cores, but I think in order to get it perfect, you need the equilibrium number where it's far enough away but close enough to generate more than it would have been without the cores. You know, it's give and take too. It really is. You get more amps with a core though. Regardless, it's just there's more power involved with using a core. Oh man, I don't know. If that works, man, that is so awesome. We're barely going to draw any amps at all. This will be great if this works. I think it's too far away to work though, but we'll see. All right, so that glue is dried a little bit. So I got to lower it just a little bit because it did not catch. I call it a catch, you know, when the trigger coil catches, you're going to see some motion and you will know that it's working. Oh, my bad. There we go. Oh, the wind's picking up. That's nice. All right. Still too high. God, I hope it doesn't like catch the core when I get it low enough. All right, if that's too low, I will put a bearing in there to level it out. See what I mean? It's like it's not, I mean, it is picking up speed, but it's very caught. It doesn't have a lot enough torque to keep it going, especially with the way I wound the coil. But it's at 0.1 amps at 18 volts. That's pretty awesome. The little engine that could. Hello, hello. How's it going, everybody? Happy Halloween. I'm trying to ground it. There we go. There it is. All right, 55 volts. This off this big coil right here. You got to get more speed than this, though. It's going to take a minute. Let me see if I'm getting you right. You mean like so, right? 70 volts. I'm gonna do it with this one. I'm gonna try that. I'm gonna hook up the connectors to that one. I'm gonna remove this one though. I don't like this. It only got up to 70 volts. That's very low. Very, very low. All right. That is a very good coil. That should be up around 200 or 300 volts. So, but it's usually, you just got to go fast for that to happen. Now let me see if what I have here will. Look, that thing will just lay right on there. That's pretty cool. Let's try that. I'm gonna have to hold the wires. It's gonna pose a little bit of a challenge. All right, let me get this started. We're gonna see what readings we get off of this coil here. Nah, man, something's not right. Already, it's not registering. Man, it looks like it should like be getting double, triple dosed, don't you think? Coil's not spinning. Couldn't be spinning. Nothing. We're not getting anything. Let me change this. Oh, might be because it's dead, though. That could be so reason why. Yeah, I gotta get it back down where it was because wow, it is not drawing any amps right now. 0.0000. I'm sure it's like 1 amp, 1 milliamp, or something really low. Maybe 10 milliamps. It's starting to pick up though. Let's see. 0.2. We're at 0.2 now. 3.3. All right, maybe I can leave it. I still think I need to drop it like another centimeter though. Because there's no cores, that'll work just fine. Haha, that was neat. Knew that was coming. So it's got a longer acceleration phase, but I think it actually might be going a lot faster with it being having the air gap the way it is. Hot. That is hot. Oh yeah, baby, and it's still moving. That's freaking awesome. Whew, that is going to leave a blister. Now, what would work very well, I believe, is if I, print like a three-way coil holder that is looks like a fidget spinner, maybe, and put it above here, and then have it be able to spin, you know. But realistically, yeah, I'm always thinking gyroscopic pulse motor or counter rotating pulse motor. What do I do to have that function the way I want it to? It's just that all the circuitry you should have a rotor with magnets or aluminum, and then you should have your rotor with the coils or your stator that moves or spins. If your stator spins and your rotor spin, that's all good. I don't know really about having the double stator. I know you can do it, but I don't know if you can do it for counter rotator. I'll give it a shot. That would be pretty cool. But what I mean by that, counter rotator, this here is a stator for a counter rotating pulse motor. You got your coils, you got your power supply, and you got your room for your circuitry all on this thing. So it all moves together, man. There's nothing holding it down. There's no power supply. We're using batteries for the power supply. And everything is contained, really. Even though it's not contained, it's contained on this disc. Yes, it is. And then it spins. You see there's a bearing in there, and it'll spin just like this rotor does. It's maglev. And that's the only thing really tethering it is the shaft. I'm working on building one that you can spin like a top, and it's not held down by the shaft. The shaft actually is part of it, and what makes it move well. There's different ways to do it. It's just the basic principle's pretty much the same. And what will happen is when the coils are triggered, they'll push one way, and the rotor will push against them and go the other way. And this, what am I trying to say? The phase, the sequence on a magnet to coil ratio, 1-to-1. One's going to go one way and the other's going to go the other way. And I've only gotten it to work with the reed switch though, as the trigger. I'm trying with the trigger coil, but I haven't been able to get it to work with the trigger coil. I think you need like 24 volts minimum, maybe 18 volts minimum to get it to work with a trigger. Works really good on 24 volts. Happy Halloween, everybody. We are going to party. So the good channels for information. I'd like to go through that real quick. Channels that I've got a lot of good information from. Yeah, Peter Hall Effect 2.0. You got Mike Does. He was here earlier. Check out their channels. Beneficence. I can't say the word, man. It's the opposite of malevolence. TV, benevolence. There's no V in it though. In either one of those words, there's no V. He's got a channel, and he shares his knowledge. He basically taught me how to wind the Litz wire. That's what these coils. These coils are twisted and connected in series and all that. They are a radial design though, used in an axial flux format. So these are what I would consider to be radial coils. Even though they're not being used radially. If that's even a word, don't know. Wow, so neat. I totally forgot what I was talking about, but it was explaining how something worked for sure. All right, let me look at the clock. We are good. We are good. What are we going to do next? I think we can look at this paper again, except I'm going to put the shiny side down so you can actually see what's going on here, I think. All right. So I have two things that I'd like to try to use with this motor. One of them is this right here. This is a filter thing. It's got rectifiers. It's got capacitors up the wazoo. And it can function as a capacitor just alone. Like instead of having one capacitor here, I put that thing where the capacitor's at, and it would be gold. And then this little transformer DC to DC buck converter booster dealio, really handy when you need some voltage. I mean, to say it's all about voltage or current would be a mistake. It's about the wattage. And, it's specific to your design whether you need more amps or volts to run it. So this one in particular, I think it requires like more voltage, especially with the pickup coil. Like a little bit more. It requires a little bit more voltage, but not as many amps, especially with the pickup coil. So like when you pull this, when you get it up close, you get that acute opaque, very distinct pattern of magnetic field there. And when you pull it back, it expands and it gets more translucent, so you're more see-through, more weak, basically, less opaque, less focused. And that it's the same with all the sacred geometry is basically depicting that very phenomenon. The farther you get away from the center or the source, the more crazy stuff is, and that's just the way it is. But it's cool. I love it out here, man. And I would consider myself running rhombicosi dodecahedrons all day. I think that's like a 72-sided shape. It's pretty freaking awesome. Maybe more. I forget. I made one in class when I was really young. By like stapling construction paper pieces together, we made these huge, dodecahedrons. Was like below what I was doing. It's pretty freaking cool. Happy Halloween, everyone. Welcome to the channel. We're just chilling. Pulse Motor Villains. Just chilling. The pump brake. At least that way I don't skin my finger. Wow, I'm happy with the way this is going, because before I switched up my coil building, I was only pulling 1500 at max power. I was like, man, what's going on? And it didn't matter what I did. I don't know. I don't even know if it was my coil. I don't know. But it's so much better now. Can't really pinpoint what I was doing wrong. I think it was because all my transistors and stuff were blowing out on me and nothing was working. And I think me flipping the way that I hook up my transistor to the front of the coil instead of after the coil really helped out, because it's a DC transistor, right? So the DC power will go into the transistor directly instead of being filtered through a coil, which won't come out DC. And be AC when it comes out, and that's what my problem was. I kept blowing stuff up because the energies weren't compatible. Hello, everybody. Welcome to the channel. It's Papa Bale. Happy Halloween, everybody. So yeah, I want to put this one and either run another motor with it, hook it directly to this one, and I just have it run another motor, or have it be like intertwined with this trigger coil right here. It's almost high enough for me to fit it right on top, but if I do that, I probably have to raise everything up a little bit. I'm blessed. This is a pulse motor. Boo, boo, boo. Let me show you the guts. All right, we got our drive coil. This right here is 160 feet of 20 gauge, wrapped and twisted in such a way that it is totally awesome. It's only 160 feet of wire though. This one right here is about half that length. It's about 10 wraps around this coil bobbin. And it's 6 strands. And they're all connected in series, a few diodes in there. This is a trigger coil, so we got drive, pickup, trigger. What I want to do is I want to put this pickup coil right on top of the trigger, like that. And that'll work so well. That'll work so well. Just have a feeling. Yeah, I don't know. Let's try that, I guess. This was my first Litz wire coil right here. It's 26 gauge all the way through. And yeah, it's got 12 wraps. It's pretty cool. Maybe we can utilize that in some way. But yeah, I'm going to have to connect all that stuff in series. So there's going to be another time to do that. But that's going to be definitely an addition that I'm going to want to make here. Oh, well, I mean, I should get used to running it a little bit higher than it normally goes. It takes a while for it to like grip and get a grip, you know what I mean? But I think putting this little one on the end of all that is going to make a superb, even better improvement on amps and actual thrust, like torque. And the trigger coil, I believe, is good enough to have that much space and the air gap in between it and the magnets. So putting it right on the top will work just fine. I think in order to build one of those devices, I have nothing. So no, I can honestly say this is a pulse motor. And you're still drawing zero point 0.0 amps. I bet you it's still like 10. All right, 0.1 amps, 17.5 volts. Let's see when it starts to shake. Let's see here. Get my tachometer. Now, if I like hook some, adhesive, some sandpaper to the outside of this thing, that would be gold too, man. I like working with wood, so having a sander like this would be great. Of course, you'd have to let it get going first before you actually start sanding anything. possibly another layer of magnets. Maybe for like a motor, yeah, like. But you know, like I've seen something like that in a flywheel operation, where the axial flux generator had north and south on either side intermingled. Whoa. Yeah, that was up around the same as it was last time. I just shot it and it was at 6,000. Wow. But you got to divide that by 3, so 2,000, which is still pretty freaking fast. Happy Halloween! Ho, ho, ho. Giving a shout out, 007. Hope your stuff is working out. I like how you built your motor out of lumber. That's pretty solid. And those magnets are so big, dude. That's pretty cool too. No doubt you're getting a lot of electricity off of that generator. No doubt. Huh. And you know why the radial coils don't really work that well with the axial flux is because everything happens within the rotor, pretty much. You only have the inside of the rotor space to work with, so you don't get to put as many coils in there unless you change the shape. Um, and that's just math, man. That's how it works. You either got to shrink the size of your coil so that it will fit, or you have to make it a different shape so it'll fit. But either way, you'll have to change your coil design from your standard radial to an axial to fit the same. Like if you're trying to maximize how many coils you can put in here, I'm thinking you're going to want to shrink the size and change the shape both, and then you have a lot of that. And then, oh yeah, about the flywheel operation. So it was a magnetically levitated flywheel, and you spin it with your hand, tabletop toy, right? But the way he had the axial motor hooked up, it was north south, north south, north south, north south, but he had it on both sides of the coils, like so. And it was, there's only one way you can really have that work. Because they're gonna lock in place the magnets. So if you ever try doing this, you'll understand what I mean. But having then the coils in the middle of that spinning around would be really good. Or you have both magnet clusters spinning, and the coils are stator. And then I believe there is motion to the solid state stuff. You just have to synthesize it. It's more of a synthesizer of motion than it is actual kinetic motion. But I do believe, in some sense, that the solid state generators move. They do. If you send a signal through it, I guarantee that coil thinks it's moving. Ba-da-bum-bum-bum-bum. Absolutely. It's a synth of motion. So, like, how do I explain it? It's all about the frequency in electricity. So this is when it's going, and when it's going, it's about 300 hertz. Okay, and you put 300 hertz into a rodent coil or an And of course, it's all going to be relative. You need a powerful like signal generator to actually force that to happen. Some kind of signal generator. Maybe powerful is the wrong word, but one that works. Let's just say that, okay? One that works, you force the frequency into it, and you've created motion. Even though it's not moving, you got a pulse in there now that the electricity is flowing. So it's like it, for all intents and purposes, it is moving at 300 hertz. And I mean, when you're doing the kinetic energy, it's transferred into speed. I mean, that's what your hertz are. Your frequency is your quote unquote speed. And it's like, but if you put it into like a rodent coil, the coil isn't moving. So, but you know, kind of is now, isn't it? And that's the only way the matrix can actually work. You know, if the matrix is real, that's the only way it can work is if you think you're in reality. You know, if the rodent coil thinks it's moving, it'll generate as though it's moving at 300 hertz. You know, if you think you work at the supermarket down the street, you're going to show up there at 8 because uh, you're scheduled to work at 8. You know, it's pretty much like the common sense factor there. It's just the way I see it. You know, it's probably can be explained in a different way. The frequency in a rodent coil and then the frequency being generated from the speed of this pulse motor. I think it's the same hertz, right? I mean, the hertz aren't any different. We could try this. I'm going to try this right now. Right. Get on the other side here. Mm. All right, we will see right now if any of that voltage is going through that circuit or not, because it's got an indicator light on it. So that's one bonus to hook that up. All right. I don't see any indication right now. So. So I think there's another way for me to hook this up, maybe. All right, so instead of this one, I'm gonna hook up that one. And that sucks. That's probably what it is. I need to get, where'd they go? Here they are. My wire strippers. Because these ends are not going to work. All right, let's do it again. We got voltage? No. All right. Happy Halloween, everybody. All right, I think I only had, that was a half-assed job I just did. I gotta do, I think if I just do this, and it might be the unit itself that is malfunctioning. But I don't know, we will find out. Okay, we are getting voltage on the other side. Very small amount, but it is working, quote unquote. Well, let me ground this baby. So that's about right. Two volts coming through. This is a pulse motor. Very awesome pulse motor. Currently the power is off to the pulse motor. You can kind of hear it winding down. I apologize for like the short feed doesn't have my introduction. It would so tell you what's going on. I apologize. But as for explaining it, we have is a 120-degree pulse motor with one drive coil, a pickup coil, and a trigger coil. Right there, lift it up, you can see trigger coil, drive coil, pickup coil, and the energy is being filtered through this trigger coil, and then it acts as a generator coil to power the system. It also acts as a drive coil when the motor's off, basically. And it does all three simultaneously so far without burning anything out. So I consider that a win. I just installed this cap bank. Basically, it's a filter, a noise filter, kind of. Just a lot of caps and rectifiers and other things connected to a board and linked in series and parallel. It's pretty awesome. So I raised the rotor about a centimeter or so. So it takes a little bit longer of an acceleration phase. It draws less amps. The longer acceleration phase is kind of bad, but oh well. I'm going to have to lift it up even more. I'm going to put this coil on top of the trigger coil. It almost fits right now, but and then it'll be the 120-degree drive circuit. And I'm pretty sure, I'm confident that it'll work being placed directly on top of the trigger coil without any problems. The trigger coil has 6,666 turns of 32 gauge. It's coreless. All these coils don't have a core in them. I was going to make a, whatchamacallit. Yeah, that's what I'm going to make. I'm going to make a, God, I don't even know what to call it, but I'll show it to you if I can find it. I think I've demonstrated, I showed it before. See, I'm going to make a plate like this, and then the coils are go in here like this. This isn't the plate, but we'll fit in there like that, and then put it on top like this. Bada boom, bada bing. Then you got a generator. Simple as that. Right now, this thing doesn't generate barely any electricity whatsoever. We get about 40 volts off of the trigger coil, and that's about the max we get off of this. But this right here, this will generate about 20. You get about 10 of these together, you got 200. And then these will flip to a drive, like just by changing where the output goes. See, the thing about this, it doesn't dump like a capacitor. Like a capacitor dumps, it doesn't just go. It filters. It allows everything to flow through continuously, and that's more what I want. I don't want my system to be shocked in any kind of way, shape, or form. I don't like that. So I think this is a great thing to have instead of like a capacitor. And have a bunch of capacitors hooked up with filters and other things. It's got bridge rectifiers on it. It's awesome for about 1,200 watts of awesomeness. It's going so good, man. Where's my tack reader? Dude. There it is. 6,000. 6,350, I would imagine. So, I mean, if I'm gonna build let me show you. And my printer's crapping out right now. I'm gonna have to get it fixed. But it printed like the base of what I was working on. So like this, it's got a little ring in the bottom here for a maglev to go. Then the pole would go straight through here and it would hug it very tightly. So it would spin when you spin the shaft. See? Then you move it all the way up. And you got your maglev in there. And this is spinning. Everything, yeah, it would just, but I gotta get my printer working again. Damn thing. No, there's a weak spot in the printer, and it's right where the tool head connects to the rest of the printer. And they got this little cover to like stabilize it, but it's a weak spot for sure. It's like it's always telling me the tool head is not connected properly. But yeah, the shaft would stick out of the base here, the bottom part, and you spin it like a top. Okay, so the stator and everything will spin with the shaft, and the rotor will be on with bearings, and it'll spin the other way. And so this way you have a mechanism that is not tethered to the table in any way. I think it would be really, really awesome. What am I doing? I'm gonna take all of this and I'm gonna make like a dreidel or a top, something. It'll be a big dreidel about yay big, just a top with all this stuff inside of it. And when I spin it, it's gonna start to move really, really fast. We're just at the beginning phases of this though. Gotta get my printer working, kind of like this, but you know, this will be on there like that. You know, whatever. Yeah, I mean, at this current point, it takes a little bit of imagination. So if you don't have that, you might not be able to see what's going on here. Because it's very early stage. And I say, what the hell? Why would I wait? Come along and join me for the journey. You don't want to, you don't have to. But I'm going to catalog everything my way, pretty much. All right. And what I mean by that is I'm going to make videos, shorts, live presentations of what I'm doing. Ones that you can look at and ones that I can look at. Wink, wink. I keep lifting this off every once in a while to show you what's underneath there. People come, people go. So I got to do it every once in a while, you know. These magnets in here are 40 by 20 millimeters. They're the strongest usable magnets I can buy. I got the cubes too, but they just don't compare to these magnets in their ability to generate and like the motion. I mean, because I literally had a rotor just like this with 3 of these cubes on it. Didn't compare at all. I mean, like, it's like, I don't even understand what the deal is. And I got them all tested. Where's my tester? It's not like I put them in there wrong. So, I mean, whoever's thinking that, dude, if that's the case, then this thing doesn't work. See, north is facing downward. North is facing down, so south is on the top. These are a lot easier to decipher than the cubes are too. And then when you're in between, It's perfect. You get your north in between. You got your south. So when you go around like that, you got your north-south automatically. Just from having 3 norths, you get your south in between. So cool. All right. What else? I don't know. Got about a half an hour and maybe 50 minutes. I need to get some more clips so that I can connect all the connections right here and then put it on top of this coil. Oh man, it's just, it sucks when you literally don't have the pieces that you need to build it. I mean, I probably have some more clips, but they're big ones like this one. And they got 1 and 5 connections instead of just the one that I need. I want to save the big ones for big projects, you know. But of course, I'm not really worried about any of it because I'm going to take it all apart, put it all away, break it all out again. This is going to continue to recycle and rebuild itself every time you come to look at it. Sometimes more slowly than others. I admit we've been doing this one for quite a while now, but like every time I do it, I add or take away something that makes it work better. So literally, man, I try my hardest to do something different, whether it's small or big, every time I do something. And all this has been in response to B. It's like, what are you doing? That's what I'm doing, man. Broad question, broad answer. But this is a pulse motor. What makes it a pulse motor? Well, the way it moves, the way it operates. What makes it move is a pulse generated by this coil right here. So when the magnet passes this coil, a certain amount of voltage is generated, and then it triggers the base of the transistor, which connects the collector to the emitter and completes the circuit. Right? Until you pulse it, it's not gonna move. That's why it's a pulse motor, because you need a pulse. You need an on-off situation for your coils. You need to, because they're electromagnets. If you have them on all the time, then it's not going to move, because it's just going to attract. That's what's going to happen. It's either going to attract to the point in between them, or it's going to attract to the magnet itself. Either way, you're going to be stuck. That's why it's got to be turned off and on repetitively. And that's why the magnets are actually the pulsar. When you got a trigger coil or a reed switch or a Hall effect sensor, how many magnets determines how many pulses per revelation. And this one, since it only has 3 magnets on it, utilizes what I call the coast, the in-between part where it's not being, the power's not on, yet you still can achieve substantially increased speed by coasting. And then it's like, well, what if we put a magnet in there and you don't coast and you get another extra push instead of a coast? It's a good question, but I think the coast is actually going to come out on top for speed. So it's like The greater degree of separation that there is, the more speed I believe you can achieve. Thanks, Pete. UK, go UK. United Kingdom. You know, my ancestors came from Greenland. Now, see, the weird thing about this switch here is that it switches on and off both the positive and negative motor terminals. So when you cut it off, you cut off the ground as well. Okay, you get what I'm trying to say? So if it needs to be grounded to work, you have to leave the switch on and turn it off manually. And I haven't decided yet whether it needs to be on or off. So, I mean, this, when it's on, when the switch is on, you get the feedback to the power supply and it tapers down. So right now it says 2.17 volts in a second or so. But if you turn off the switch, all that residual disappears. And you've now cut off the ground to the power supply. And the power supply, so I mean, this switch basically severs the connection to the ground and to the positive. Yes, pulse motors are a go. Mm. All right. Since I've been talking trash about the cubes, I'm not sure. I'm going to make the cube rotor. So that's northbound. Hmm. No, no, this one is not maglev. I have a maglev base in case I wanted to put a maglev on there, but this is just a magnet. Um, I need another big one on the disc itself to maglev it. At least the way I do it. All right, so do we want to do 6 mags or just the 3? We'll try it with 3 first. I don't know. We'll see. With the bigger magnets, you don't need precision. That's what makes them so fun, is because you're just throwing it all together and it works. And it works well. So to have the range that the big magnet has is beneficial when you're in a hurry. All right, I'm going to lower this a little bit. Hopefully that'll work. If not, like I said, man, like hands down, I like the other magnets better. This should work though. This one will be good. Here we go. Oh, maybe not. We'll see. So we're at 20 volts. I've been trying to get an amp draw here, and it's not. It's like trying to poke a vein that's really, really deep, and you miss, man. That's just how it feels. Oh, lawnmower man. Here we go. I should probably get out there and do that myself, actually. Looks like we got something now. I'm going to let it run for a little bit. Hopefully, it will continue to increase in amp draw and speed. Looks like we got her. Oh, yeah. Let's see how fast this one will go. 20 volts, 0.1 amps so far. Well, I mean, let's look at the shape itself. It's a circle. It's got 360 degrees in it. So 9 times 4 is 36. My neighbor's mowing the lawn. It's pretty good. All right, let's see what the amp draw is. Still 0.1 at 20 volts, man. That is a low amp draw for 20 volts. Yeah, nine was the funnest for me. I had to make a special rotor to do 9. 25 volts, 0.2 amps. Yeah, I like it though. I mean, it's smooth. It's very quiet. It's rattling a little bit, but it's still smooth. $5 watts, I think. So it's 25 volts and 0.2 amps. 5 watts. I mean, but if you can tell, the other rotor, I mean, it doesn't compare. It just does not compare. Let's get the speed reading on this. 1,555 divided by 3. 223.3. Oh. 0.2. So the first one there, 25 and 0.2 amps. So yeah, 5 watts. Fluctuating between 0.2 and 0.3 milliamps. But I mean, for 25 volts, that is really low. Yeah. I don't know if this one's still picking up speed even. Maybe it is. We'll see. Yeah, a little bit. But it's slow. It's slow. So we got that. And then we got this. I think this is going to be too low now. But just by like a hair. So if the magnet down here has any effect, I think it's pulling against this bearing right here. Oh man, that did not go the way I wanted it to. Excuse me. All right. So we'll scoot it out a little bit. All the coils are now out a little bit. All right, this is a little high right now. Hello, how's it going, Comfort? All right, Beat, I'll check you later, man. Thank you. Yeah, that's really high, so I don't know. Uh, where's my wrench? There it is. All right, we're at 25 volts and 0.2 amps so far. 200 milliamps. Now, why do I think that the magnet performance is so different? Definitely the range is what's making it so much better. That means that the coils don't have to be precisely placed. That is so weird, man. So cool. All right, so I'm going to explain this circuit one more time. Now that the power is cut, it switches on so it can ground. If the power is cut, actually, let's force it to go through the circuit. So now the ground is cut, so it won't default to ground. It'll default to the system. Just with the flip of a switch. That's awesome. So the trigger coil is hooked up here to these clips through these resistors, one for the in, one resistor for the out. You got your, and one end connected to the base, and the other end is grounded. Well, it's the same end. So one end is connected to the base, one end is grounded, and the end that is connected to the base is connected also to this capacitor bank over here, and the diode, which, you know, traps it, and then it will go here back to the collector. As long as the magnet is passing the trigger coil at a significant rate, it'll open the base to the collector even though the power's off, because that's how it works. That power will dump into the collector and run through the system. It's going to drop into the collector at the same time the base is triggered, so it works. And that's how the trigger coil now functions as a generator. a trigger coil, and a drive coil when the motor's off. But of course, there's a limited amount of potential energy when you turn off the motor. And that's just the way life is. So the more times it spins, the less and less and less energy you will have recycled. That's just the way that it works, man. If you're going to use copper wire, it's going to work that way. You know, you got loss. Now, I'm not using a core, so I don't have core losses. But, you know, lots of loss. There's definitely loss happening. Hello, hello. Thank you. Thank you, thank you. This is just been real awesome, this one especially. Like every time I start this bad boy, it goes. And it goes fast every time. It's like if I, you know, polished up the edges a little bit, I might be able to sell it as a toy. Indeed. But since I'm using this big capacitor bank right here, it's a little bit more forgiving than all that precision. It really is. It's a just-in-time situation here, and so when the energy can flow, it will flow, basically. And I'm glad I hooked it up like that. So basically, when the magnet passes over, it's going to open up the transistor every time. And when there's voltage built up in the cap bank, it's going to hit the collector from that bank every time the base hits, every time the magnet passes. Every time the magnet passes, you will also feed the capacitor bank. This will not move forever, no matter how you hook it up. Doesn't matter. Doesn't matter, and nobody will show it. You haven't seen it because it doesn't exist. Now, what you can do with the solid states are awesome. You got Rotor coil, you got your Tesla coil, you got different types of coils that are solid state and they generate. Okay, they don't have to move or have a rotor or even any permanent magnets to work. But as soon as you turn the power off or your battery dies, your time is limited. And that's just the way it is. It might be a longer limitation in some cases. It could last for 1,000 years in some cases. But it will eventually dissipate to nothing. That's the way it works. But you can utilize every last drop of the energy. But because I'm not saying that if there was zero loss, then you can do whatever you want. If there's no loss, everything is possible. Okay, but I can guarantee you there will always be a loss. That much I can guarantee. And that's where the struggle is now. How do we reduce the loss to nothing so that this will stop happening? That's why the efficiency rate is like 98, 99%, because you can't. Now, what I do believe you can do, it's not perpetual motion necessarily, but if in a counter-rotating situation, you can continuously increase speed until the device breaks. That, I believe, can happen. You can continuously increase in speed until until you reach the threshold of the device physically. That's different, though. That's not perpetual motion. Perpetual motion is you reach a speed and you maintain that speed forever. That's perpetual motion. I don't believe in that. I don't believe that's possible. I believe as soon as you level out, you start to decrease immediately. and you get a fluctuation like so in the wave, or whatever power is coming and going. It fluctuates at that point, and you go like this. But you have to maintain the power. And then it's not with the power off, it goes like this. Power off, you go like that. And so what I've done here with the trigger coil is I've made it so that when I turn it off, it goes down slower. Goes down slowly instead of just stop. I've actually got it to the point, if anybody knows when I say residual effects in the power supply, how it still has a registry when you turn it off because of the power coming back to it. Well, when you flip a switch, that happens instantaneously. And I got it to the point where it was actually going up. It would get down to the point where it would start to level out, and then it would increase in the amount of residual effect that the power supply was having. And that, I said, it will increase for a couple seconds, and then it will taper off slowly. And that's exactly what I built it to do, and that's exactly what it does. Happy Halloween, everybody. And everything that like perpetuated it in my mind, made it happen and made it a reality, was I was given an idea to make a braking system for this. And what I ended up actually doing was creating a booster for when the power was off, and reverting the trigger coil to a generator coil, which then through diodes and capacitors dumps all its energy back into the system. And it's not a SSG, so I don't have to worry about it not working. Now, I was thinking about making an SSG circuit, but I don't know. It doesn't seem to me like I'm going to need to do that. I think this one works better. I haven't had any trouble with this transistor at all since I started building this. Pretty much this, maybe I've been through two, and I think the first one that I used still works, but it's really, and if you want to save, capacitors and transistors, you want to hook up the power supply directly to the collector of the transistor. You don't want to do the coil first, because then it has potential to oscillate and become AC. It pretty much does become AC when you do coil first. And most transistors that I know about are not AC transistors. So right there is an incompatibility, and you should probably put the DC power into the transistor first. Hell yeah. Happy Halloween, everybody. But I'm going to have to call it for now. I might be back later on this evening. And I'm going to try and get that other coil hooked up and show you guys all what I'm talking about. All right. Peace out. Have a good day. Catch y'all later. Going to the bus stop. Bye now.